So for this PowerPoint, we are going to be talking about the practicals associated with this module. This is the first of two reactions associated with this module. It's the investigation of factors which affect the rate of reaction between dilute hydrochloric acid and sodium sulfate. So as a quick overview of the reaction, the sodium thiosulfate reacts with hydrochloric acid to form a solid precipitate of sulfur. The formation of this precipitate means that the solution will become cloudy, and so the rate at which this cloudiness appears can be used as a way to measure the rate of reaction. Here are the equations for the reaction. They'll probably be quite useful for you to learn. The rate at which this precipitate forms can be changed by changing the conditions under which the reaction is carried out. So in this experiment, you will study the effect of changing the temperature of the sodium thiosulfate solution. So for this reaction, you are going to need a 10 centimeter cubed measuring cylinder, a 25 centimeter cubed measuring cylinder, a 250 centimeter cubed conical flask, a piece of paper, a stopwatch, 1 mole hydrochloric acid, a thermometer, and access to two different sets of sodium thiosulfate solution at two different temperatures, which here are shown as 5 degrees and 60 degrees. If you take a look at the diagram in the top right hand corner, it just gives you an example of how to set up your apparatus and how you will be running the experiment. So for the method, I have again included the apparatus diagram, so hopefully it'll help you follow this a little bit easier. You are going to draw a cross on your piece of paper. You are going to measure 25 centimeter cubed of hot sodium thiosulfate using the 25 centimeter cube measuring cylinder and pour it into the conical flask, recording the temperature of your solution. You are then going to use the 10 centimeter cube measuring cylinder to measure 5 centimeter cubed of the hydrochloric acid. You are going to place the conical flask with the thiosulfate solution onto the cross and add the hydrochloric acid. Swirl in the flask to mix the contents, and at the same time you're going to start your stopwatch. Look down at your reaction from above to get a better angle of seeing the cross and when it disappears. Once the cross disappears, you're going to stop the stopwatch. You then need to record the time taken for the cross to disappear and repeat steps 2 to 6 with different temperatures of thiosulfate, which are shown to you in the table to the right. So for the final part of this reaction, you're just going to create a graph of your results. Now, I've included example figures here, and when you plot your graph, you should see that as the temperature of the thiosulfate solution increases, the time taken for the cross to disappear should decrease. And you should know from previous videos that this is because as temperature increases, the rate of reaction increases. So the second reaction associated with this module is the investigation of the factors that affect the rate of reaction using a gas collection method. So in this reaction, you'll be using magnesium and hydrochloric acid, and the magnesium will react with dilute hydrochloric acid to produce hydrogen. These are the equations. The rate at which the hydrogen gas is reduced can be used to determine the rate of reaction. In this experiment, you will study the effect of changing the concentration of the hydrochloric acid on the rate of the reaction. So you will need a 250 centimeter cube conical flask, a single-holed rubber bung, a delivery tube to fit the conical flask, a trough or plastic washing up bowl, a 100 centimeter cube measuring cylinder, a 250 centimeter cube measuring cylinder, a clamp stand, and a Boston clamp, a stopwatch, a magnesium ribbon in 3 centimeter length, and 1 mole of hydrochloric acid. So to carry out this reaction, you are going to set up the apparatus as shown in the diagram to your right. You're then going to measure 20 centimeter cube of the 1 mole hydrochloric acid used in the 25 centimeter cube measuring cylinder. You're then going to pour the acid into the 250 centimeter cube conical flask. We're then going to fill the other measuring cylinder with water, making sure it stays filled with water when you turn it upside down and clamp it above the trough. You're going to add a 3 centimeter strip of magnesium ribbon to the flask, plug in the bung quickly into the flask, and start the stopwatch. You're then going to record the volume of hydrogen gas given off every 10 seconds. Continue in time until no more gas appears to be given off. Repeat steps 2 to 5 using 10 centimeter cubes of hydrochloric acid and 10 centimeter cubes of water, making sure that your total volume is 20 centimeters cubed. So for the final part of this reaction, you are just going to plot your results with the volume of hydrogen gas across the y-axis against the time on the x-axis for both the concentrations of the hydrochloric acid. So as you can see, I've again included some sample results and an example graph for you. These are the links for all the resources I used to create the video. They're also available on the GCSE website for you if you wish to access them.